triangle congruence proofs, excuse me. And the way we're going to do that is we're now going to start taking our proofs one step further than proving congruent triangles. So this involves CPCTC, and what that means is corresponding parts of congruent triangles are congruent, and that's what we've been talking about all up until this point anyway. If you have a triangle congruence statement, like triangle A is congruent to triangle DEF, you know 6 things from that statement. You know that angle A is congruent to angle D. Remember that order really matters here. A is first, D is first. You know that angle B is congruent to angle E. You know that angle C is congruent to angle F. You also know that the corresponding sides are congruent. So you would know that AB is congruent to DE. You know that BC is congruent to EF. And you know that AC is congruent to DF. And this is helpful because when we went to prove congruent triangles, we didn't need to know all of these 6 pieces. We really only needed to know 3 of them in varying circumstances. So if we're able to prove triangles are congruent, we can then conclude something else that we didn't know about the triangles. So let's write a proof this way. I'll show you what I mean. Here is one case. Pause the video and copy this down. The very first thing that you need to do is mark your diagram, and what's really nice is this one's marked already. PQ is congruent to RQ. PQS, the angle PQS, is congruent to the angle RQS. And looking at this, I want you to decide, why are these triangles congruent? I see one more piece here. Pause the video, say to yourself, write it down, why are the triangles congruent? Now, welcome back. You can see that the triangles are congruent by side, angle, side. Notice that I'm not trying to prove triangles congruent. I'm trying to prove that angle P is congruent to angle R. Well, if I can show that these 2 triangles are congruent, I'm going to know P is congruent to angle R by CPCTC. So let's start by writing our proof, just beginning by trying to get that the triangles are congruent. So I'm going to start with one thing at a time. Let's start by showing that we have a set of congruent sides. Well, PQ is congruent to segment RQ, and that's given, and that makes one of our sides, one of the sides we need in order for us to prove the triangle's congruent. So I'm going to write in my margin S for side. Next, I see I have a set of angles that are given, and I'm working now on the second requirement for side, angle, side, the angles. Angle PQS is congruent to angle RQS, and that is also given. And that's the A of my side, angle, side. Then finally I need the last side, and that is QS is congruent to QS, and that is by reflexive. And I'm going to put an S out here in my margin, and now I'm ready to say the triangles are congruent. And now remember, the order that you write the triangle congruence statement is very important. It says what parts are corresponding. So triangle PQS is congruent to triangle RQS. Notice how I'm lining up the corresponding pieces. Side, angle, side. I'm going to use my reference numbers 1, 2, 3. And now that I have that the triangles are congruent, I'm able to say that angle P is congruent to angle R. And that is by CPCTC. Corresponding parts of congruent triangles are congruent. Now, it's really important you remember what that means. You never know when I might ask you that again. And that really is all there is to it. We're just taking our proof one more step. Now, let's try another one. I'm going to try one more proof, and then when I'm done, you're going to try the next proof, and then check your answer when I'm finished. So, pause right now and copy the diagram down. Now, again, the very first thing that you do is mark your diagram with what you know. I know that angle L, there it is congruent to angle J. And I know that KJ is parallel to LM, and I have that marked appropriately. Now remember, anytime we're given parallel segments, what that's telling me is I need to look for congruent angles. And it just so happens that this angle here is congruent to this angle there. They are alternate interior angles, and they are both inside the triangle. Now, parallel does not mean congruent. I need to look for one more piece of information concerning these triangles, and it just so happens that they share a side. So the triangles are congruent by angle, angle, side. And now we're ready to write our proof. Notice we are not trying to prove the triangle's congruent, we are trying to prove these angles, but we're going to be able to do that because these are going to be corresponding angles, and once I show the triangles are congruent, I'm going to know the angles are congruent as well. So let's start. I have my statements and my reasons. Angle, angle, side. I'm going to work on that first angle requirement. Angle L is congruent to angle J. And out in the margin, I'm going to put an A for angle, and that is given. Now, I'm going to work on the second angle. In order to prove that the second angles are congruent, I need to know that I have parallel segments. KJ is parallel to LM, and that is given. Now, the reason we knew those angles were congruent, angle KML and MKJ, is because they are alternate interior angles, so I had better say that. Angle KML and angle JKM are alternate interior angles. That is assumed from diagram. Now that I know that the lines are parallel and those are alternate interior angles, I know that the angles are congruent. Angle KML is congruent to angle JKM. And the reason for that is if lines are parallel, then alternate interior angles are congruent. There is my second A. So I need one more thing. I need to know that the sides are congruent. And the final side is that KM is congruent to KM. And that is the reflexive statement. So let's write that in. KM is congruent to KM. Reflexive. Ooh, having some trouble with my pen here. Okay, and that is the side that goes along with the angle, angle, side. And now I'm able to say that the triangles are congruent. So remember, we got to line up our pieces appropriately. triangle, and I'm going to have to page back and forth a little bit, scroll up and down because I can't remember what the letters are there. Triangle KML is congruent to triangle, let's see, KJ. And that is by angle, angle, side. Remember, we're putting our reference numbers in here, 1, 4, 5. But we were not starting this with wanting to prove that triangles were congruent. We were starting this by wanting to prove that the angles are congruent. And it just so happens that LKM and JMK are corresponding. So we are able to say that they are congruent. Angle LKM is congruent to angle J. Ooh, I'm scrolling here again. JM. What is going on? Trouble, trouble. JMK. There we go. And that is by CPCTC. Done. Not so bad. We're really just taking it one more step. Next, I want you guys to try one on your own. Here is the next one. Copy the diagram down. This is the end of my video. I am going to have the answers to this proof on the haiku site, and then also the homework is on the haiku site. So I'd like you to do this, check your answer, and then start working on the homework. Hopefully I'll see you tomorrow.